Hey, Mr. Estrada here, and our learning target for this video is I can determine if a given set of sides can form a triangle. Alright, so let's get to it. Example 1 says, can the following lengths represent the sides of a triangle? So we are given lengths of 5, 10, and 20. So I want to just stop here and help you visualize this. So we have a line segment that's 5 units long. We have another line segment that's 10 units long. And then we have another line segment that is 20 units long. And what this question is asking is if you can form a triangle with these 3 line segments. So let's go ahead and try it. So I'm going to take this line segment and I'm going to put it here. And then I'm going to take this line segment and I'm going to place it here. Now, you can see that if I try to manipulate this any way, that these points here will never touch to form a triangle. And I can actually show it to you here via this website, Hot Math. You can see here that CB is 5, so this is a 5 unit long segment. AC is 20 and AB is 10. And I can try to manipulate this any way, and these will never touch to form a triangle. So it actually turns out that you cannot form a triangle with these 3 measurements. So the answer to example 1, can the following lengths represent the sides of a triangle? The answer is no. Now, why is that? Why is it that they can't form a triangle? And it goes back to this theorem that we call the triangle inequality theorem. And the triangle inequality theorem, simply put, says the sum of the lengths of any 2 sides of a triangle must be greater than the 3rd side. So given any triangle, if you add up any of the 2 sides, that sum must be greater than the 3rd side. So let's take this back to the first example. Let's take this idea back to the first example. Let me just go ahead and erase this. So the triangle inequality theorem says the sum of the lengths of any 2 sides of a triangle must be greater than the 3rd side. So 5 plus 10 must be greater than 20. And you know, it does say any 2 sides, so we don't stop there. Whoops. Example 1. 10 plus 20 has to be greater than 5. And then finally 5 plus 20 has to be greater than 10. So let's go ahead and see if this holds true. 5 plus 10 is 15. 15 is not greater than 20. So right there you have it. It cannot be a triangle because the sum of 5 and 10 is not greater than 20. So that's the actual explanation. So I'm going to just go ahead and write that. The sides cannot represent the sides of a triangle because the sum of 5 and 10 is not greater than 20. Let me just make that smaller font. All right. Now, even though 10 plus 20 is 30, and that's greater than 5, and even though 25 is greater than 10, if it doesn't hold true for all of the combinations, it cannot be a triangle. All right, so the triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the third side. AC plus CB has to be greater than AB. CB plus AB has to be greater than AC, and so on and so forth. Let's try another example. Determine if the following lengths can represent the sides of a triangle. So what you want to do is you want to verify that the triangle inequality theorem holds true for these three sides. If it holds true, then you have what could represent a triangle, and if it doesn't hold true, then we know the sides cannot represent a triangle. So 5 plus 10, is that greater than 12? 10 plus 12, is that greater than 5? And then finally 5 plus 12, is that greater than 10? Well, let's see. 5 plus 10 is 15. That's greater than 12. 10 plus 12 is 22. That's greater than 5. And 5 plus 12 is 17. That's greater than 10. So the sum of any two sides is greater than the third side. So this could be a triangle. So let's go ahead and write that. These sides, can represent a triangle because the sum of any two sides is greater than the third side, or the side that's left. Example 3 says, in triangle ABC, AB is equal to 5 and BC is equal to 3 feet. Write an inequality to represent all the possible values for side AC. So what we have here is we have side AB, which is 5 feet, and we have side BC. BC, so it should be over here. Side BC, which is 3 feet. And we're being asked to find the possible values for AC. Now, this is important. Values is plural, meaning that there is more than one possibility for the side AC. And you'll see why in a second. All right, so the way I'm going to begin this problem, by, I'm going to label AC X. I'm going to say AC equals X. So the triangle inequality theorem says the sum of any two sides has to be greater than the third side. So our three sides are 5, 3, and X. So using the triangle inequality theorem, I know that 5 plus 3 has to be greater than X. I know that 3 plus X has to be greater than 5. And then finally, I know that 5 plus X has to be greater than 3. And then I'm just going to solve each one of these inequalities for X. So 5 plus 3 is 8. So we know that X has to be less than 8. And then I'm going to subtract 3 here on both sides. I'm just following the steps for solving an inequality. I get X is greater than 2. So far I know that X has to be greater than 2, but X has to be less than 8. Now you're going to solve the last one here, and it's going to give you X has to be greater than -2. And we're just going to reject this because of the negative here. So this gets rejected. We don't pay attention to it. So what I know from here is I know that X has to be greater than 2, but it has to be less than 8. And that's my final answer. And that's why it says possible values. because x could be any number between 2 and 8, but it can't be 2 or 8. It could be any number between 2 and 8. So this is our answer. All right. I hope this video helps. Take care.